Welcome to this explainer. I am absolutely thrilled to share this one with you. For centuries, humanity has shared this collective, almost sci-fi dream, the idea of creating machines that could actually think. And what started as just a fantasy has steadily evolved into literally one of the most transformative technologies in human history. Today, we're going to trace the phenomenal story of artificial intelligence. We're talking about a journey spanning decades of intense research, frustrating setbacks, massive breakthroughs, and undeniable global impact. So let's get started.
Okay, let's dive into this. Back in 1950, the brilliant mathematician Alan Turing posed a simple, yet incredibly profound question. Can machines think? To figure that out, he introduced what we now call the Turing test. It was basically a conceptual experiment to see whether a machine's conversation could become completely indistinguishable from a real human's. And honestly, that single question, it was the spark that ignited the entire field of computer science.
So here's our roadmap for today. First, we'll cover the dream and the winters. Then, we'll look at the machine learning shift, followed by the generative revolution. After that, we'll unpack how AI actually learns and wrap up with the future we choose.
Starting off with Chapter 1, The Dream and the Winters, where we look at the origins of AI.
Now, what's really interesting about this slide is the sheer optimism of the time. To understand where we are today, we have to rewind to the 1940s and 50s. Right after World War II, computers were just starting to get powerful enough to run complex calculations, and visionaries began wondering if these giant, humming machines could actually imitate human intelligence. The term artificial intelligence was officially coined in the summer of 1956 by computer scientist John McCarthy during a now historic workshop at Dartmouth College. It was built on this incredible belief that machines could eventually simulate every single aspect of human learning and reasoning. And at that workshop, the optimism was just overflowing. Many researchers genuinely believed human-level AI was just a generation, or literally a single summer away. Well, spoiler alert, it took a little bit longer than that.
Yeah, reality quickly set in. After that early excitement in the 50s, we hit the 1970s and 80s, eras that became known as the AI winters. Why the winters? Well, early AI systems were okay at solving simple puzzles or playing basic games, but real-world intelligence proved far more difficult than anyone anticipated. Computers back then simply lacked the processing power and the massive amounts of data required. So, as enthusiasm faded into disappointment, funding completely dried up, plunging the whole field into a deep freeze.
However, the science didn't entirely stop. Even during the darkest days of those AI winters, when funding was incredibly scarce, dedicated researchers just kept their heads down and kept building. They pivoted their focus to creating expert systems. Now, these weren't the general human-level intelligences they originally dreamed of, but they were highly capable programs designed for very specialized, narrow tasks, things like medical diagnoses and engineering calculations, and that quiet work kept the flame alive.
Let's move to and see how this builds into Chapter 2, the machine learning shift, where the rules start to change.
Moving into the transformative 1990s and 2000s, the fundamental rules of the game completely changed. Machine learning became the new paradigm. This is an approach that allows computers to learn from examples and recognize patterns in huge datasets, rather than having a human programmer hand code every single rule. Think about the massive contrast here. Before, scientists had to hard code endless logic rules into the computers, but with machine learning, they developed methods that let the software essentially figure out the patterns for itself just by looking at data. It was an absolute paradigm shift.
And this new approach led to a massive turning point. In 1997, a highly specialized IBM system named Deep Blue achieved the unthinkable. It actually defeated the reigning world chess champion Garry Kasparov. This wasn't just a win in a board game, right? It was definitive, undeniable proof that machines could outperform human beings in highly complex, deeply strategic tasks. The winner was officially over.
Bringing us to Chapter 3, the generative revolution, the modern explosion of AI.
Accelerating into the 2010s, AI capabilities completely reshaped our tech landscape, triggering what we call the deep learning era. And this was fueled by a perfect storm. Huge advances in graphics processors, the sudden availability of massive datasets from the internet, and highly sophisticated neural networks. Because of this combo, deep learning systems rapidly integrated into our daily lives. Suddenly, our phones had facial recognition with remarkable accuracy. We had real-time language translation, virtual assistants, and autonomous driving research accelerating at breakneck speeds. AI was just suddenly everywhere.
But then came the 2020s.
and what we call the generative leap. Here's the monumental shift. AI learned not just to analyze information, but to actually create it. Modern generative systems have moved way beyond just sorting data. Today, they can write essays, generate complex software code, compose original music, produce beautiful artwork, summarize massive documents, and answer questions in natural language. This is exactly why businesses, schools, and hospitals are increasingly relying on AI to drive productivity today. Let's jump into Chapter 4, How AI Actually Learns, where we're going to demystify the tech.
So how is all of this creation actually happening? First, we really need to ground ourselves in reality and strip away the sci-fi magic. AI doesn't think exactly like humans do. It's not a tiny person sitting inside a box. Instead, modern AI is entirely based on statistical mathematics. It learns statistical patterns from enormous amounts of data. Imagine billions of text fragments or images flowing into a system. The AI is simply doing highly complex math to predict what should come next based on those massive patterns.
To look under the hood, here's the 6-step process for how an AI actually learns. First, scientists collect massive data sets. Second, they train mathematical models using incredibly powerful computers. From there, and this is a big one, they adjust billions of parameters to improve the AI's predictions. Next comes testing the performance and reducing errors, followed by deploying the model for public use. And finally, they're continuously refining it with new techniques. And I really want to stress here, training and adjusting require immense computational power, highly specialized hardware, and can take months of uninterrupted time to complete. It is an enormous undertaking.
And that brings us to Chapter 5, The Future We Choose, focusing on the human equation.
So the crucial point is, having seen the history and the mechanics, we must recognize that we're standing at a critical juncture for our society. It's a highly complex balancing act. On one side, we have extraordinary opportunities, significantly faster scientific research, improved medical analysis, personalized education, and automating all those repetitive tasks. But on the exact same coin, we face significant responsibilities and challenges. We have to navigate potential biases in training data, massive privacy concerns, security risks, the very real threat of misinformation, and job displacement across various sectors. Researchers, policymakers, and companies are actively grappling with these dynamics right now to develop safe, robust guidelines.
Bringing it all full circle, artificial intelligence was not built overnight. These incredible, sometimes daunting systems we use today are the direct culmination of decades of mathematics, engineering, computing power, and just unyielding human curiosity. When we fire up an AI today, we are literally standing on the shoulders of Alan Turing in 1950, John McCarthy in 1956, and all those dedicated researchers who labored through the long, cold AI winters.
Which leaves us with this final, really important thought. The future of AI is not only about smarter machines, it is about wiser decisions by the people who create and use them. The story of artificial intelligence is still unfolding, and the choices we make today about how it's designed, governed, and utilized will absolutely determine whether it becomes one of humanity's greatest tools or one of our greatest challenges. Thank you so much for joining me for this explainer. Keep learning, and I'll see you next time.